this video is going over part 2. Um, Now, I know it says no desmos. It's no desmos graphing. You will still have a calculator. You can do basic multiplication, addition, subtraction, division, etc. It's just not the graphing calculator. So the majority of this is to be done algebraically, how we learned it when I taught you the notes. So let me get my pen here, and I'll go over these questions with you. In this first one, you are subtracting rationals. Okay, so when you add or subtract fractions, you need to remember that we need a common denominator. So you would write down on your scratch paper the original problem, okay, and then we want to get a common denominator. So we talked about how we multiply the denominators by each other. And what we do to the denominator, though, we have to do to that numerator on that side as well to keep the equation balanced and equivalent. So then on the left side here, x times x is x squared, and it's over that common denominator of 8x. 8 times 8 is 64, that common denominator of 8x. Once you have the common denominator, you can combine it to a single expression in the numerator over that common denominator. Then from there, you see if you can simplify any further. Now, looking at your answer choices, I do see that answer choice here. So if none of the other answer choices are also equivalent, you could stop there, okay? But that top is factorable because that's a difference of two squares, meaning the square root of x squared is x, difference, it's a minus sign, and then the square root of 64 is 8. So you can do one positive and one negative, and then it's over 8x still. Now, once you have it factored, if something was the same in the numerator and denominator, something meaning a factor, you would reduce. But here, the x plus 8, I don't see an x plus 8 in the denominator. X minus 8, I don't see an x minus 8 in the denominator. Okay, and then like an x here, I don't see an x on its own as a factor in the numerator. So here, nothing can reduce. So I guess they just are having you leave it as that answer choice. Okay. Alrighty. Then here, this, when you have parentheses butted up next to each other, that is multiplication. Okay, if there's no sign in between, you're multiplying. It says assume no denominators equal to 0. We always are going to assume that because we can't divide by 0. So to multiply, you are going to want to factor what you have first to see if anything will reduce, and then we'll multiply across whatever didn't reduce. So I'm going to first factor this numerator on the left. So that's a difference of squares. That's like what we just had. So we're going to have a b plus 8 and a b minus 8. And then I'm going to try to factor denominator over here. Okay, 225 is also a perfect square. And remember, you've got that purple reference sheet I gave you with all the perfect squares and perfect cubes. You can also, you're going to have a basic scientific calculator. So if you need to try and take the square root of 225, because I think that one's actually, I think the list only went up to 12, and that's 15 squared. So the square root of 225, you'll be able to do that in your calculator that is not graphing. So the square root of 225 is 15. So this will be b plus 15 and b minus 15. Okay, and then the left side, b minus 15 does not reduce or factor. B plus 8 does not factor. So now you look for common factors in numerator and denominator to reduce. So I see b plus 8 here and here. So those get to reduce. I see b minus 15 here and here. So those get to reduce. So now the only things left in your numerator is b minus 8. And the only thing left in your denominator is b plus 15. And that won't reduce either. So let's see, there it is, answer choice A. All right, which expression is equivalent? This is a difference of perfect squares, okay? Because this first term, I could take the square root of this, or actually, no, I cannot. 18 is not a perfect square. Let's see. It looks like we'll have a GCF that we can take out, and then we may have a perfect square. So look at your list of factors. You're looking for the factors of 28 that are also something that's a factor of 128 that's also a factor of 18. And you could even try dividing 128 by 18. It doesn't divide evenly. That's not it. But if you just want to work backward to check those numbers, you could do that. Let's see. There's a 128. Be 64, 32, and 4. 4 doesn't go into 18. Let's see. 16 and 8. Neither of those go into 18. Yeah, it doesn't look like anything bigger than a 2 will go into both of those. So 2 is going to be my GCF. And I actually could have seen that if I looked ahead here. You can see the GCF on all of your answer choices is 2. So 2 is the GCF that you're taking out. So then you'll be left with 9y to the 4th minus 64. Now what you're left with here is a difference of squares, because I can take the square root of this, and that would be 3y squared. And I can take the square root of 64, and that would be 8. So remember what you're doing when you do difference of squares is you take the square root of both, one gets a plus and one gets a minus. So you end up with these two nearly identical binomials. Don't forget that GCF of 2 is still out there. It doesn't disappear. Then you always want to double check. Can I take it any further? Here's another difference, but these are no longer perfect squares. So I cannot take that one any further. So that's 3y squared plus 8 and minus 8. So that's here. All right. Factored form. Again, I don't have the graphing desmos to plug these in and compare the graphs. So I actually have to factor. Now looking at all of these, you can see they all have either a 4t plus 5s or 4t minus 5s as part of the factored form. So most likely, I mean, obviously that's going to be one of those. We need to figure out, should it be a plus or a minus? So looking at the format, I can see my variables are both cubed and that it's a minus. So this is a difference of perfect cubes. So again, you're going to get your formula chart or the reference pages that I gave you, those purple pages. It has the difference of cubes formula on it. I'll write it here for the sake of reviewing. But if you have two perfect cubes being subtracted, it is going to factor to be the difference of those cube roots times a squared plus their product plus b squared. So that's the formula. So we can see, okay, we've got a difference. So my signs should be just like this. So eliminate anything that doesn't have the correct sign. So it should be a minus in the binomial and then a plus plus. So this is a minus in the binomial. Now this might be factored further, possibly. I mean, we'll take a look back at that one. It's a different format, but let's look at these. It should be a minus first, so these two are out. Okay, so it looks like it should be D just based on the signs, but I'm just going to be careful and go ahead and write this out. So if I take the cube root of the first term, here, the cube root of 64 is 4. So, and the cube root of t cubed is t. So this is going to be 4t in place of all the a's. So I'm going to have 4t everywhere there was an a. Go ahead and put all the parentheses here. And signs. Now this entire thing is squared. So put parentheses around it, squared, plus, it's going to be a plus, and whatever goes here is also going to be squared. All right, then I'm going to take the cube root of my b term, and whatever I get is going to go in place of all these b's. So the cube root of 125 is 5, and the cube root of s cubed is s, so 5s. So when I write those in, then I can do some simplifying. And I can see I've got 4t minus 5s, and then 4t squared. So the 4 gets squared and the t. So that's 16t squared. And then here I go ahead and simplify. 4 times 5 is 20. And then you can do st or ts. I usually just write mine in alphabetical order. And then again, the 5 and the s get squared. So that would be 25s squared. So we can see here, I think that's a typo. I think it's supposed to be D here, and they have a typo and typed it as a T. So that should be S. I will go in and fix that on the actual review to make sure that that's correct. All of those I think were supposed to be typed that way. Well, actually, yeah, they're all supposed to be typed that way. So that should have been it. But I will adjust that now that we've caught that typo. Make sure that gets corrected. Yeah, that's it for that one. All right, here you have a sum. So again, you've got to know, actually my class is about to start again, that's what the bell is. So I'll do this in a separate video. I'll finish this one and then stop the video. So it'll be the first 5 and then the second 5 in a separate video. So this one is a sum of 2 perfect cubes. So again, this formula is going to be on your reference sheet. Okay, bring all those purple reference sheets I gave you. Because if you just look at the formula and the way that this should be written out with the signs, you can eliminate some of your answer choices, because you should have a plus in the binomial and then minus plus in the trinomial. So a plus, good, good, out, out. So I've eliminated 2 answer choices already. And then look at your trinomial, it should be minus plus. There's only one that has all the signs in the right place. So, and you're given that formula. So this, you were able to use process of elimination here. Now I'm going to show you working it out just so you understand if you weren't able to eliminate every single one. You're going to take the cube root of that first term, which would be 3a. So a 3a is going to go everywhere in place of a. And then you're going to take the cube root of that second term, which would just be v. So v is going to go in place of all the b's. So v, v, v. And then we already had the signs listed out. So it's 3a plus v. And then remember to square both of those. So it should be 9a squared minus 3av plus v squared, which that does check out. It's right here. So just eliminate, process of elimination with knowing your formulas. And you don't even have to have them memorized. It's just knowing what formula you should use and then look at the formula chart.